The array, the simplest data structure around. It's such an integral piece to the puzzle of computing that it's a native component in most of the programming languages you'll ever use. Now, you've likely been told that an array is a list of items of a certain type. Now, this type of explanation helps in understanding what you could use an array for, but it's not an accurate representation of what an array actually is, as you need to understand it. An array is simply a contiguous piece of memory. It has a fixed size once initialized, which means once you set it, it is locked at that size until you no longer need it. If you did want the illusion of having a resizing array, say one that expands in size, you'd have to make an array of a new size, copy the contents of your first array to your second array, you get rid of your first array, and then you append whatever elements you want to the end. Now, this constraint isn't as bad as it sounds, because it makes everything in it directly accessible with just a little bit of math. If you think of a variable as an alias for where your value is actually stored, then the memory address of your array is the memory address of your first element in that array. Now, to understand why that is, you first need to know how to calculate the address of any element in your array given its index. You take the memory address of your array, your base or your B, the size of the types of elements that you're storing, in bytes of course, and then the index of the element that you want to access. You could also take the lower bound or your LB, but in this case we'll just be starting from 0. Then you apply the formula as shown, size times index at your base, and then bam! Let's go through an example, actually. See, we have our base here, we have our width, which is 4 bytes, we have our index that we want to access, which is 2, or it's the number 3 here, and our lower bound is of course 0. So here's how we do this. We take our memory address 4 times 2 minus 0, which is 2. 4 times 2 is 8. We add that to our memory address, and then this is the address that we get. Nice. If we look at another example where I equals 0 this time, we'll see why the memory address of your array is the same as the memory address of your first element. You take your size times 0, which is of course 0. You add your base to it, and then there you go. You get the memory address of your array, which is the same as the memory address of your first element. Now, what you could do is that if you wanted to access your first element, you could just dereference the variable name without the use of the array operator at all. But please don't actually do this in production. It is very, very bad advice. Do not ever do this unless you're just showing off a party trick. See, before the advent of programming languages like C, programmers had to figure this stuff out on their own. Arrays have been around since the 50s, but back then, computing the memory address of every element you wanted to access was your problem. More steps, of course, meant more room for error. Programming languages took that step away. All you need to simply do is write out the index, and it handles the math for you via the compiler. You're still going to make mistakes with arrays, but this is not going to be one of them. And this is one of the many, many problems programming languages solve.